The way a dry cleaning machine works, really dry cleaning means, quote, absence of water, because perchloroethylene, of course, is a liquid. And the reason that's necessary is that if you have like a wool garment like Chris has, if the water and heat are in there together, it causes that fiber to tighten up, and that's where you get shrinkage. When it goes into perchloroethylene, that doesn't happen. It's a water-free system, and the heat, the drying temperature is much lower. It's about 130 degrees, as opposed to, if you had water in there, you'd have to have a much higher temperature. So the clothes go in and they actually wash here in the system. When it's finished washing, it's a real high-speed spin, and it spins as much of the perc out of there as possible. And then, while staying right in this machine, this is a washer and dryer, then the drying portion starts. And as it pulls those vapors out of there, they go back into a condenser, and those vapors are condensed, and the fluids go back down into the equipment. We do not want this machine leaking into the ground and contaminating groundwater. We live here too. So, the conscientious owners have done a great job, in my opinion, of helping to clean up this industry from what it once was. But we're on the brink of going another step. We're really on the brink of new technologies, I think, really having an impact. So the objective is, with perchloroethylene, as with any solvent in this day and age, is that you don't release any of it into the air. You certainly don't pour it down a water supply, and you don't pour it out on the ground. And that's been very achievable for the last 15 or 20 years. Before that, the machines leaked. You had barrels of perc external to the machine, which were transferred. But this unit is so sealed we can't get to it, and like you say, you can barely smell it, if at all. And also it has a pan underneath it, so if the seals in the machine were starting to fail and perc was dripping out, it would be caught by the pan rather than going into the floor and then down into the ground, because that's what happened historically. But also, perc has to be cleaned. So the way it's cleaned, and just as if you cleaned water, it's distilled. So there's a still within the machine, and the perc is actually boiled. Again, that perc goes back into the machine, and at that point, it was pristine. It's clean, it's continually cleaned like that. So this is what we call still bottoms. When you distill, there's always residue left over, the contaminant, and so those are collected and kept in barrels, and then Safety Clean comes around about every 3 weeks, and they take that for proper disposal.
First and foremost, I guess this is the byproduct that's produced, but it's not hazardous. It's mostly water and insoluble soils, things like dirt, lint, dyes, things like that. The previous machine, let's see, this one, so right here, this is the cleaning solvent, and thus far we've yet to have to add any to it. It reclaims everything that's used, cleans it, recycles it. This is the still. The previous machine, the still, was like about 150 gallon capacity, is almost constantly running, cleaning the solvent. This one has a 6 gallon capacity. It's run every 10 loads for about 10 or 15 minutes. There's a lot less steam usage from the boiler housing. One of the biggest differences from this side here is that this is going to be loud for a second, as it's going to circulate the cleaning fluid to warm it up. You feel it, yeah. You feel it. It's starting to get really cold. Still temperatures. As you hear that the wheel door is locked. We can open up the drum. You actually see that there's, I think probably because the vents are all closed in the building, that I don't know if you saw a little bit of like vapor come out of there because it's so cold. Let's see here. So we cleaned one load of clothes, and this is the amount of lint I'm going to have out of it. I mean, it's virtually nothing.